Hey everyone, welcome to this channel. Today we will learn about refractive index of different materials and mediums from class 10th science chapter light. So चलिए start करते हैं from the definition part. Refractive index is measure of the bending of a ray of light when passing from one medium to another. So you know very well that when light passes from one medium to other, light gets bent. और वो कितना कम या ज़्यादा बेंड होगी ये हमें बताता है रिफ्रैक्टिव इंडेक्स. So refractive index is a parameter that is directly related to bending of light. Okay. So as you can see, one medium is glass and other one is water. And incident ray is at same angles in both of these medium, that is at 60 degree. Still bending will be different. Bending in case of glass will be more as compared to water. So refractive index of glass will be greater than refractive index of water. So this is the theoretical part. Now we will look at mathematical part. Mathematically it is given as relative refractive index. What is the meaning of this word relative? You must have studied relative velocity in class 9th, which means that velocity of one object with respect to other. Similarly, refractive index is relative refractive index is refractive index of medium 2 with respect to medium 1. And we will write it as n. n से हम represent करते हैं refractive index को, and in the base or subscript we write about the mediums 2 and 1. Okay. So refractive index is always a comparison between two mediums. Why is this comparison? Because refractive index दोनों mediums पर depend करता है. For example, this second medium is glass and this first medium is air. So now if we change this first medium, then bending of light will also change. कितनी ज़्यादा bend होगी light वो change हो जाएगा if we change this medium. So if bending is going to change, that means refractive index will also change. Okay, so that's why relative refractive index is always a comparison between two mediums. Now what's the formula? Formula is V1 upon V2. V1 is speed of light in medium 1 and V2 is speed of light in medium 2. How are you going to remember this? On the left hand side, it is N21, 2, 1. And on the right hand side, you will write it as 1, 2. Order को आपने reverse कर देना है 1, 2. Okay. Similarly, here it is N1, 2. And on the right hand side, it is 2, 1. Okay. V2 upon V1. So that's how you can learn this formula. Now we will look at another term, that is absolute refractive index. Now what is the meaning of this word absolute? In case of relative refractive index, we have a freedom to choose these 1 and 2 mediums, about these mediums. Okay, we can choose this medium to be anything. This medium first can be air, water, glass or any other transparent liquid or diamond. Same goes for medium 2. So हमारे पास पूरी freedom रहती है to choose these two mediums. But in case of absolute refractive index, first medium is always going to be vacuum. First medium हमेशा vacuum होगा and second medium can be any other medium. वो कुछ भी हो सकता है. It can be any other medium. It is represented simply by n and formula is C upon V. C is the speed of light in vacuum, that is maximum 3 into 10 to the power 8 meter per second, and V is the speed of light in that medium. Okay. So this is not a new formula, as you have done in this last slide. Refractive index of medium 2 with respect to 1 is given by V1 upon V2. Now in case of absolute refractive index, first medium is vacuum and in vacuum we represent speed of light by C. So V1 will now be C. And V2 is the speed of light in that second medium. We can write that simply by V. So formula is C upon V. So यही same formula है for the absolute refractive index. It's not a new formula. Okay. If you want, you can write a subscript about this medium कि ये second medium क्या है. For example, if it is glass, you can write a G, small g in this base of N, that is absolute refractive index of glass. Okay. Now there is this one table in your NCERT textbook where absolute refractive index of different mediums is mentioned. Okay, for example, for air it is 1.0003, that is approximately equal to 1, and that is very obvious because we know that speed of light in air is approximately equal to speed of light in vacuum. So this ratio, that is C upon V, speed of light in vacuum upon speed of light in air. Now these two numbers are almost equal, then this ratio is going to be equal to 1. ये approximately 1 ही होगा. And we know that this v, that is speed of light in air, is slightly less than the speed of light in vacuum. So this ratio is going to be slightly greater than 1, and that is why there are there is a number after 3 decimal places. Okay, so it is approximately equal to 1. And you can remember this one thing, that absolute refractive index is always greater than 1. It is always greater than 1. It can never be less than 1. Why? Because speed of light in any medium can't be greater than the c, that is speed of light in vacuum. यही maximum speed है in vacuum, right? But in case of relative refractive index, it can be less than 1, it can be equal to 1, and it can be greater than 1. Okay, so it is very important that relative refractive index can be anything, but absolute refractive index is always going to be greater than or equal to 1. Now in this table, they have mentioned refractive index of different mediums. As refractive index increases, जैसे जैसे refractive index increase हो रहा है, that means bending is also increasing. Bending उतनी ही ज़्यादा हो रही है. Okay, and if you look at the maximum value, it is for diamond. So यहाँ से बहुत बार question आता है कि for which medium refractive index is maximum? It is for diamond, as diamond is the hardest material on this planet. Okay, diamond is the hardest material. That's why refractive index is maximum for diamond. That means light will bend maximum in case of diamond. सबसे ज़्यादा light bend होगी diamond के case में. Now, how are we going to use these values? अब हमें refractive index तो पता लग गया for different mediums, but what can I do with this value? I can calculate speed of light in any medium if I know refractive index of that medium. Okay, for example, for diamond के केस में refractive index है 2.42, so I can calculate speed of light in diamond. Okay, refractive index is 2.42 and it is equal to C upon V. C is speed of light in vacuum, that is 3 into 10 to the power 8 upon V is the speed of light in diamond. Okay, so this 2.42 will come in this denominator and V will go at this place of 2.42. Okay, so it will become speed of light in diamond will be 3 into 10 to the power 8 divided by 2.42, which is approximately, if you calculate this, it is 1.24 into 10 to the power 8 meter per second. Okay, so this is the answer, that is speed of light in diamond is 1.24 into 10 to the power 8 meter per second, and we have calculated this value directly by refractive index. So we can do that for any other medium also. We can calculate speed of light in any medium if we know refractive index of that medium. Okay, now another type of question that generally come is like this. These are the values of refractive index for kerosene, turpentine and water. Okay, so these are the values. Now question that arises here is, in which medium light will travel fastest? Light सबसे ज़्यादा fast किस medium में travel करेगी? If you look at the formula, N is equal to C upon V. And you can clearly see that refractive index is inversely proportional to the speed of light in medium. V के वो inversely proportional है. Okay, so speed of light will be maximum when refractive index will be minimum. जब ये minimum होगा, and it is minimum for water. So answer will be water. But again, if question is in which medium light will bend most, सबसे ज़्यादा bending कहाँ होगी light की? Okay, so this confuse a lot of people. In which medium light will bend most? Light सबसे ज़्यादा bend कहाँ होगी? Where refractive index will be maximum. Refractive index एक parameter है that is directly related to bending of light. Okay, so जितना ज़्यादा refractive index उतनी ही ज़्यादा bending. So answer will be turpentine. सबसे ज़्यादा bending होगी where refractive index will be maximum, और सबसे ज़्यादा speed कहाँ होगी? Where refractive index will be minimum. So you have to read the question very carefully and then only you will answer. Okay, so now is there any other way to calculate refractive index? अभी तक हमने देखा कि we can calculate refractive index by speed of light in different mediums. But is there any other way? Yes, there is. If you remember, we have done Snell's law in our last video. Okay, and what is Snell's law? Snell's law gives this ratio to be constant. This ratio is sine of angle of incidence to sine of angle of refraction, which remains constant, and this constant is known as refractive index. So we can calculate refractive index by using Snell's law. Only if we know these angles, अगर हमें angle of incidence और angle of refraction पता है तो. Okay, so now if you are doing this chapter for the first time, so हो सकता है आपको sine के बारे में ना पता हो. Sine is a trigonometric ratio that is related to sides of triangle, and you are going to do this topic in much more detail in your mathematics portion. Okay, but as per now we are going to remember these values. Sine के अंदर हम कुछ भी angle substitute कर सकते हैं. This theta is the angle. We can substitute any angle here, 0 degree, 1 degree, 5 degree, and for each and every angle there is particular value of sine. Sine की कुछ ना कुछ particular value है, but we can't remember all of those values, right? So here are these commonly used angles: 0 degree, 30, 45, 60 and 90, जो बहुत ज़्यादा use में है. Okay, and you have to remember the value of sine for these angles. So sine for 0 degree is 0, sine for 30 is half, sine 45 is root 2 upon 2, that is also written as 1 upon root 2. Okay, sine for 60 is root 3 upon 2, and sine 90 is 1. So these are the values of sine theta at these different angles. Now we will see that how can we calculate refractive index by using Snell's law. So there is this simple question where we have to calculate refractive index. This is any medium, and this is the first medium, as that is air, and you can see that angle of incidence is 60 degree and angle of refraction is 30 degree. Okay, so we can look at the values of sine 60 degree and sine 30 degree from that table, and we can use those values. Okay, angle of incidence is 60 degree and sine 60 degree is root 3 upon 2. Angle of refraction is 30 degree and sine 30 is 1 upon 2. Now you can calculate refractive index of this medium with respect to air. Okay, refractive index of this medium M with respect to air will be ratio of these two values, root 3 upon 2 divided by 1 upon 2. Okay, and this will answer will be root 3. So you can leave your answer here only. So this is very simple to calculate refractive index using Snell's law. So that's all for this video. In this video you learned what is refractive index and what are the different formulae for refractive index, how can we use those formulas, and that's all. So thank you for watching this video. Take care of yourself and stay safe and healthy.